In this video, I want to talk about how to compare box plots. If I have more than one, how can I compare them? So let's start with some guidelines. We can start by comparing the medians. So we want to compare the locations of the medians. We want to compare the interquartile ranges. So interquartile range is represented by the length of the box. And this compares dispersion and how spread out or compact my data is. We want to compare the range, so this is shown by the actual whiskers. This is another aspect of dispersion. We want to look for signs of skewness, if our data is symmetric or not. If it's not symmetric, does each of my box plots show the same kind of asymmetry? And we also want to look for potential outliers, and outliers tend to be marked in a box plot by a point to let us know that it is an actual outlier. So before I look at actually comparing them, I want to talk about this idea of skewness a little bit more. The skewness is a measure of asymmetry of a distribution. It explains exactly how far away it is from being symmetric. A left skew, also known as a negative skew, this indicates that the tail on the left side is longer than the right side. This means that the bulk of my values, most of my values, including most likely the median, lies to the right of the mean. In other words, the median is larger than the mean. On the other hand, a right skew or a positive skew, this time the tail on the right-hand side is longer than the tail on the left. So this means that the bulk of my values, including my median, is to the left of the mean. In other words, the median is smaller than the mean. So now let's look at some box plots. Let's look at comparing these two box plots. The first thing I want to compare is the medians. We can see that this top one has a much larger median since the bar here is further than to the right. The interquartile range, the length of the box, is about the same. However, this one up here also has a much larger range, which is determined by the length of the whiskers. They both start at the same point, but this top one goes for much longer. We also want to look for signs of skewness. This one is roughly symmetric, whereas this one is very skewed. In particular, these two really short pieces, remember each one of these pieces has 25% of the data. And so smaller pieces indicate a lot of data, very compact on each other. So we have very compact data here and then a long tail on the right. So this is right skewed. So this tells me that this data is about evenly spread out and has a much larger range. However, this value is heavily skewed right. I have most of my data built up toward the lower end and not as much of a range. Let's look at this example here. Here are 5 experiments that we did to measure the speed of light and the results that we got. We can see these outliers that happened in experiments 1 and experiment 3. So we can see experiment 3 had a lot of outliers. This red line is the true speed of light, so experiment 4 did the best job of actually measuring this. We can also see that experiments 3 and 5 have these really small areas here, and this one in particular, this whisker. So this would tell me they have a lot of data on the lower end and not as much on the upper end. So both of these would be right skewed. Whereas the rest of these are going to be roughly symmetric. This one has a little bit of more compact box here, which might indicate a small left skew. But overall, we can see that experiment 4 was the best and experiment 3 was the worst. The only two that kind of got close and didn't over measure this were considered outliers.